using StatCrunch for two-way analysis of variance. This video uses the example titled Femur Impact in Car Crash Tests. This example uses the data contained in the table titled Crash Test Force on Femur with two factors, femur side and vehicle size category. We need to enter the data from this table into StatCrunch. First, enter all sample values in one single column. In this example, we enter the sample values in the first column named Crash Force. Next, enter corresponding row names for each sample value in a second column. The row names for each sample value are entered into the StatCrunch column named Femur Side. Finally, enter the corresponding column names for each sample value in a third column. The column names for each sample value are entered into the StatCrunch column named Car Size. In the top menu of StatCrunch, select Stat, then select ANOVA from the drop-down menu and TwoWay from the submenu. The TwoWay ANOVA dialog window now appears. At the top of the window, select the columns that include the data to be included in the analysis. For Responses In, select the column containing the sample values, which is the column named Crash Force in this example. For Row Factor In, select the column containing the row names for each sample value, which is the column named Femur Side in this example. For Column Factor In, select the column containing the column names for each sample value, which is the column named Car Size in this example. Click Compute to display the two-way analysis of variance results. We begin by testing the null hypothesis that there is no interaction between the two factors. The corresponding p-value is shown in the StatCrunch display as 0.763. This p-value is greater than the significance level of 0.05, so we fail to reject the null hypothesis of no interaction between the two factors. It does not appear that femur crash force measurements are affected by an interaction between the femur side and vehicle size category. There does not appear to be an interaction effect. For the row factor of femur side, the corresponding p-value is shown in the StatCrunch display as 0.3498. Because that p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no effect from femur side. That is, the car crash force measurements do not appear to be affected by whether the femur force is being measured in the left leg or right leg. For the column factor of car size, the corresponding p-value is shown in the StatCrunch display as 0.7343. Because that p-value is not less than the significance level of 0.05, we fail to reject the null hypothesis of no effect from vehicle size category. The femur crash force measurements do not appear to be affected by the size of the vehicle. On the basis of the sample data in the table, we conclude that the crash force measurements on the femur are not affected by an interaction between the femur side and the vehicle size category, they are not affected by the femur side, and they are not affected by the vehicle size category.